So right now I am going to go over genetic algorithms for trading, and this might be a long project, so strap in, but I'm gonna show you absolutely everything that I learned and everything I know. And yeah, so I'm gonna type out this prompt. I'm gonna use ChatGPT for all of the great coders out there that hate me for using this. I love you too. So I'm gonna use ChatGPT here, and I have a bunch of screenshots here and a transcript here. Above is a transcript to one of my teammates' walkthrough of genetic genetic algos. I also included all of the code that was provided in the screenshots. I want you to go step by step to explain the entire transcript and all of the code that goes along with it. Make sure to go over all of the code so that I can copy it and then run it on my VSC. So your goal is to teach me back everything above. Yep, that's it. This is perfect. This is perfect. Life is perfect. I'm so glad that you're here. Okay, so let's bring over our code over here, and we're just going to go ahead here and say folder v VGEs VGE, and then we're going to say vid1.py. There's like 12 vids, so we got a lot to go over, and this is stuff that I'm still trying to comprehend. But at the end of the day, genetic algorithms, we've done our own little testing on them. But as I mentioned before, I worked with a researcher for almost a year on this stuff, and it was way over my head. So I feel like I am now 3 years deeper, or at least 2 years deeper. I don't know. Anyways, genetic algorithms are inspired by Darwin's theory of evolution. They are used to find optimal solutions by mimicking processes such as selection, crossover, and mutation. In algorithmic trading, these algorithms help in optimizing trading strategies by evolving potential solutions over generations. The transcript describes a genetic algorithm for optimizing trading strategies. It includes concepts such as genotype, phenotype, crossover, and mutation, and explains how these are applied in the context of trading. Population and individuals. A population is a group of potential solutions. Each individual in the population has a genotype, a list of integers representing parameters. Genotype and phenotype. Genotype is a list of integers like 23, 65, 32, and so on. The phenotype is the actual parameters derived from the genotype, which are used to evaluate the individual's performance. The fitness function evaluates how good an individual trading strategy is based on metrics such as Sharpe ratio, drawdown, and ROI. Crossover and mutation. Crossover, combining parts of two parent solutions to create offspring. Mutation, introducing random changes to an individual to maintain diversity. So let's go over this code step by step. Let's go ahead and let's put all of this in there because I feel like this is I'm walking through these research with GPT. Okay, that looks better. Now let's walk through all the code here. This is pretty simple stuff. I'm not going to spend any time on it. Just a bunch of imports. Backtrader, I don't even have backtrader in here. It's amazing. I just don't use backtrader anymore. Sorry, Charlie. I probably have it in here. But that's okay. Let's go ahead and pip install backtrader. Shows you how old this information is, but it doesn't mean it's bad. Just means I wasn't ready for it. Because I tried to go through this before and it was a little advanced for me. So, but I was going through it yesterday and I'm there now. I'm ready for this. So if I'm ready and you've been here the whole time, then hopefully you're ready as well. You're probably smarter than me, so I appreciate your thoughts. Appreciate your thoughts. Appreciate love, mostly. Okay, now it's pip installed. These are just a bunch of imports. Okay, this is loading the data here. Load in data. Okay. We don't have this data, dude. So we got to get some data from somewhere. What type of data was he using? I think he was using 1 minute data. Let's go ahead and see if we can find some 1 minute data somewhere. I know I can. I can do anything. One minute data. I got some right here, but I want to get a lot. So let's find one that has 1 minute data for a long time. Just looking through some of my files here. I'm looking for some data. There's a lot of data. I can just pull this from somewhere else, sure. But I just feel like there's gotta be one in here that has a lot. I mean, 30 weeks of data is a good amount, but let's just use that for now. I can up it later. Matter of fact, I don't want to use the 1 minute. I think it's too noisy, from my opinion. It's just my opinion, though. My opinion means nothing. So, just here, existing with you. Just here, existing. Shout out to all the Guilfoils out there that are stuck in their old ways. It is what it is. I love you. Import default. What is this? This line doesn't look right. This import line looks off. Oh, this is so good. There's a lot here we're going over. You're right, the import is wrong. There we go. Backtesting from backtesting.indicators. We're gonna have to figure out where that file is. It's okay. This is what we're doing here today. So if you're interested in genetic algorithms, we got a lot of genetic algorithms coming up here. I'm attacking this viciously. So we're creating folds now. What are folds? Folds are pieces of data. The data is divided into folds. The code creates indices for training, validation, and testing. Let's say explain more about what folds are. I'm just going to put some things on here. So we've got our folds now. That's chill. It's essentially The way I understand folds is segments of your data. Defining the strategy here, so you can see this is just a engulfing strategy, and you define the strategy in text, which I found very weird, but it's okay to not know everything. If you know everything, you're wrong. If you know everything, you're wrong, because you don't, and I don't either. But Guilfoyle does, and there's a lot of smarties up in here. That's what I love about coding. Big egos. They know it. They know it all. Defining the strategy. A strategy class Golf is defined using Backtrader. The strategy uses indicators like the Stoke RSI, the whole moving average, and QQE and ATR. Okay, then we obtain the phenotypes here. So this is how we obtain the phenotypes. And you can see here, this is different than what we were doing before. If you were here before, the reason there's a big jump in this code, and I don't know if you remember, but when we did genetic algorithms before, it could run forever. It could run forever and really search forever. Why? Because there's so many different things to test. Now, that's actually a problem if you think about it, because if there's unlimited things to test, a genetic algorithm like we built in the past is going to take forever to run. But do you see this small change here? Hey, Guilfoyle, listen up, bro. This one's for you. This is for all the data compression geeks out there. Much love to you. Keep pushing me. I'll get there someday. But if a genetic algorithm is testing bajillions of things and it's using just regular floats and integers, that's going to take longer than using NumPy. So you can see everything's been switched to NumPy integers here. Let me know your thoughts on that. In my mind, that makes sense. If NumPy is going to run 100 times faster, that means that we're going to find the answers 100 times faster if we're only using NumPy instead of regular floats and integers. I don't know everything though, so I'm just learning this stuff with you live every single day here. Appreciate your kindness. Patience with me. I take time because in my mind, I didn't grow up in this game like some of you guys did. I appreciate you guys expecting me to be as good as you at coding or trading or things like that. It really does push me. It does. Just be kind. Creating a function to get the KPIs. Okay, so this would look at our KPIs, which are Sharpe ratio, drawdown, and ROI. That makes sense to me. So the KPI function, this function retrieves key performance indicators, KPIs, such as Sharpe ratio, drawdown, and ROI from the strategies analyzers. So this is running the genetic algorithm. The actual running of the genetic algorithm is not shown in the screenshots, but here's a general structure of how it would look. I'm not going to do this part because I didn't send it to her. But we will do this eventually. Next. Genetic algorithm setup. The deep library is used to create individuals and the population, define genetic operations, crossover mutation, selection, and evaluate individuals based on their phenotypes. Evaluation function. The evaluate function runs the backtest for each individual and returns the KPIs. Running the algorithm. The genetic algorithm is using EA simple, which evolves the population over several generations to optimize the trading strategy. Okay, so here's the complete code again. They just had to make that little update. I want to ask this because I think this is interesting. Divide the data into folds for trading and sliding window approach. Using a sliding window approach. Also explain the sliding window approach. I studied this last night, so I understand it a bit, but I want to go deeper because if this is new to you, then If it's new to me, then it might be new to you. I don't know. Again, I know we got a lot of smarty pants in the room at all times. So I appreciate you holding me to your standard. I'm not there yet, but I love you and I appreciate I love competition. So, you know, anytime I see something that I don't know, I'll go figure it out. And it might take me way longer than you, but it's okay. I'm okay with going slow because I know I'll never stop. Folds are segments of your data that are used in a process called cross-validation, which is a technique to evaluate the performance of a model. Instead of using a single train test split, cross-validation divides the data into multiple segments, which are folds, and uses each segment as a test set while the rest of the data is used for training. In a typical K-fold cross-validation, the dataset is divided into K equally sized folds. The model is trained K times. In each iteration, a different fold is used as the test set, while the remaining K1 folds are used for training, K minus 1. The performance metrics are averaged over the K iterations to provide a more reliable estimate of model performance. Sliding window approach. The sliding window approach is a variation of cross-validation specifically useful for time series data. In this time series forecasting and trading strategy, backtesting, maintaining the temporal order of data is crucial. The sliding window approach ensures that the model is always trained on past data and tested on future data. In the provided code, folds are created as follows. So you can see this is where we fold it up here. Here's a breakdown. Fold size is here. Let's go ahead and pull that over here. Here we go. So we're saying up to 3 empty lists here. And then we're saying fold size is calculated based on the granularity of the data. This determines the number of data points in each fold. Number of folds, n folds, is the total number of folds created from the data set. Indices for folds, valid IDX, train IDX, and test IDX stores the indices for validation, training, and testing folds. Loop to create folds. The loop iterates through the data in steps of 6 times fold size to create folds for the sliding window approach. For each step, it defines indices for training, validation, and testing sets. The sliding window approach is illustrated in the code. We initialize the indices and initialize empty lists to store indices for validation, training, and testing sets. Generate indices in the loop. For each window, define valid IDX as the current fold, train IDX as the subsequent fold, test IDX as the next fold after the training set. Then we shift the window. Move the window forward by 1 for the next iteration. Train the model on the training set. So you can see we're always training on different and then looking at non-scene. Validate the model on the validation set. Test the model on the testing set. Okay. Let's keep this going. Let's just keep going. So the next part of this is I need to pull up the second part of that video. That's why I need to do. So let's just do it. Let's just do it, dude. Where did you go? Where'd you go? So how long are you? You're a 25-minute. So now I need to find you on my YouTube. And yeah, dude. Keep going at their necks every single day, every single second. Come on, let's go. Let's go. You going? Are you going? I'm going. Where you at, V? Where you at, V? Where you at, V? Section 1, intro. Or you at V? There you are. There you are. 25, 22. That's it. Found it. Found you. Luxie, you still here? You still with us, Luxie? You a good girl. Now up here. Wait. That ain't it, shorty. Give me the transcript, please. Just downloading the transcript. So like I mentioned, I hired a researcher a couple years back. It was way ahead of me and still way ahead of me in this game. So it was actually pretty hard to understand what the heck he was talking about, but it's part of the game, And that's what's great about this is that now we can understand it. Dang, I can't get the subtitles off that one though. Okay, that's fine. It looks fine. Why can't I get the subtitles off it? Subtitle YouTube. Don't say it. Don't say it. They don't like that. They don't like what I'm doing right now. Gotcha. Perfect. So where should I put this? I should put it in the in here so we have it, the readme here. Okay. So this is just a bullet point overview. I think this is the same one. Yep. Perfect. I was like reading this yesterday. This is the transcript of the first video. All right, that's the transcript. Okay. So below is the transcript to the video my teammate was teaching me about these GAs. Please go over everything and reteach it to me from what was said in the video. Also, go through all the code in the pictures. So I can then copy the code and run it. Below is the code we have so far that came from the video prior to this. Please teach me everything and give me all code so I can learn. Okay, so let's give it the all this code. And now I need to give it all the images. So what should I call this? I'm gonna call this section 1, vid 1 and 2. Vid 1 and 2. Okay, so let's go ahead and get all of the images out of here of the code. So where did we stop? We started at KPI. Perfect. Perfect. So that's screenshot 1 here. I love AI, dude. This is so insane. I literally wasn't able to understand this, but now I can because we have AI. It's insane, dude. Where did we get to here on this one? So we got down to cerebro.add analyzers, trades, and sharp. Get them out of here. Get them all out of here. Longs and shorts. Wreck everybody. Please. Leave only algorithmic traders. I'm sorry. If they watching right now and they're still trading by hand, come on, blood. Okay, so we're down to there. Perfect. Dude, you don't understand how much time and effort this man put into this. So I'm excited to get his whole brain. And I'm excited to watch this stuff back, to be honest. Because me plus AI explaining this is way better. I mean, not that like I'm a good explainer or I'm good at this, but the at least you can understand my accent, kind of, hopefully. Okay, so we got down to here, which is awesome. Not that one. I want this one. So we're gonna have all the code by the end of this. So we got down to 10, end 10, end pop 10. I've also got some papers we need to go over to really fully understand this stuff. I'm doing the hard things people aren't gonna do, dude. So, you know, this is not easy stuff, and it's not expected that anybody understands this because I don't. But with time, I for sure will. That's the great thing about life, dude. The great thing about life. You just keep going, bro. Keep going. Do hard things every day. If your day's not hard, you're not living. Just straight up, B. Straight up. KPDF. How you gonna switch on me like that, cousin? That's funny. Switch over to Kaggle. Sick, bro. Okay, so do we have everything here now? Yes. We do. Okay, now I want to go ahead and key up these papers here. So let's go ahead here and say recommended paper recs. Dude, we have everything. There's literally only things between you and I and absolutely taking over this world is time. So keep coming back. I'm gonna keep bringing the ideas. Most of them are going to be trash. Let's be honest. Most ideas are going to be trash. But that's okay. It's okay. If you don't understand why, then that's okay too. All right, we got paper recommendations here. We're going to go over those next. You got any questions? Throw them in the chat. Throw them in the chat. Are those frames from a YouTube video? Nah. Cheesecake says, if you use genetic algorithms to data mine, please use the permutation test in the book by Tim Masters, Permutation and Randomization Test for Trading, because it's very easy to overfit. The test will also allow you to save your output of sample data for something that you find is worth it. Nice. Oh, dope. Thanks, Cheesecake. Hey, KW, what up? 777. See, Silvio's in Tokyo? Dude, have a great day. Or night. Whatever, wherever it is. Whatever time it is there. Have a great everything. Have a great life, bro. All right, let's go ahead here and read through it. Let's break down the entire genetic algorithm step by step, including all necessary code snippets, and explain each part. So these are the imports. We already went through these. This is the strategy. We already went through that. This is getting the getting phenotype here. So we got phenotypes, we got genotypes. This gets the KPIs. Okay, let's get all of it. It's all in there. Cool, cool, cool. And then here, the rest of the code sets up and runs the genetic algorithm using the deep library. These are for my teammate. He made videos for me to try to get my peanut brain to understand things, but my peanut brain is a little slow. You know how that goes. So I took screenshots of the video. So the rest sets up the genetic algorithm from the deep library. Evaluate. So you can see evaluate uses golf here. Let's go through the additional code segments shown in the screenshots. This part of the code defines a function to calculate the KPIs. Okay, I need to update this. Get KPIs here. Def get KPIs. Paste that in. This segment of the code trains the genetic algorithm using defined KPIs. Continue, blood. Continue. Okay, so this is the best solutions list here. For IDX. This is tough, man. This is tough. It's always hard going off somebody else's code base. For IDX. For IDX. Def evaluate. Evaluate. Here, I'm gonna say, can you output the full code? Starting at above is my code. Can you output the full code starting after the get KPI function? And then I want to talk about, or I want to get an overview here of everything that was. Sure, let's continue the code where it left off. Perfect. Let's get this out of here. Hey, you actually did exactly what I asked. Good job, baby girl. Good job. Copy. Okay, that looks great. Now, the only thing is this, the golf thing.